In this video, we're going to solve our linear programming problem about how many buses and vans the school should rent. So our first step in solving the problem is to graph our inequalities in the Desmos graphing calculator that we wrote above. So we have 4 inequalities here, and we're going to graph all 4 of them on the calculator. So I already have that done. Here's what that looks like. And then our second question defines the feasible region as the overlap of all of the inequalities graphed. Find the feasible region on your graph. What shape is it? So it's a little bit hard to see with all the colors going on here what region it is where all 4 of the inequalities are overlapping. I'm going to turn off the green and the purple ones here because I can sort of mentally put in that I have an inequality at the y-axis and one at the x-axis. So I know that it needs to be in this first quadrant here and then only look at the other 2 inequalities. So I'm going to turn those off. And now I can see that the area of overlap is going to be this triangle shape region here, where the red and blue are overlapping and where we are in the first quadrant. So this is a very narrow, weird looking triangle, but it's a triangle. So that's going to be my answer for question 2. And then question 3 says to find the coordinates of each corner point of the feasible region. So since this is a triangle, it's going to have 3 corner points. If it was a 4-sided feasible region, then I would be looking at 4 points. But this feasible region is going to have 3. And as usual, I can find the coordinates by clicking on the Desmos graph and clicking on the gray points. So I see that there's the 3 points 10, 0, 7, 15, and 12, 0. Those are the coordinates of those 3 points. So I will type those in here. And step 4 is to plug each corner point into the objective function to find the cost of each. So here is my objective function that we wrote in the last video. Remember that x is number of buses and y is number of vans. So my cost is $1,200 per bus and $100 per van. So when I'm looking at these answers, this first answer of 715, that represents that I'm renting 7 buses and 15 vans. So I'm going to plug that into the cost formula. So that's going to be 1,200 times 7 plus 100 times 15. And do that on my calculator. I should get $9,900. Then I'm going to try my next corner point. So one of these corner points is going to be where the cost is minimized. It is not possible for it to be at a point that is not one of these corner points that we have identified. It's just a matter of determining which point it is. So now we're plugging in 10, 0, 10 for x and 0 for y. So this is going to be 100 times 0, which I know is just going to be 0, and that's going to be $12,000. The last point I don't really need to plug in terms of finding the answer because I know that if 10 buses is not the cheapest option, then 12 buses obviously is not going to be the cheapest option either. It's definitely going to be more than 10 buses, but I will plug it in here just to get the value for how much that's going to cost, and when I do that, I should get $14,400. So those are the 3 possibilities, and those are the 3 costs. So the minimum value for cost is going to be that $9,900. And the coordinates of that point are 7 for x and 15 for y. And so to minimize the transportation costs, they should rent 7 buses and 15 vans. And the minimal transportation costs are $9,900. And then we just need to paste the link or image of our graph.